Hello, eighth graders. This is Miss Carenta. Just going to talk you through the Wednesday assignment. So you're going to find the link to this virtual egg carton in your Wednesday folder and also in the quiz. So I'm going to show you how to navigate this. So this first one is click on Nice. What type of rock is Morton Nice? So I'm going to click on Nice, and that corresponds to this top one. So whatever's on the top here, it corresponds to that. So some of the oldest rocks in the world include the gneiss found in the Minnesota River Valley. The Morton Nice, which is 3.6 billion years old, is coarsely crystalline, foliated metamorphic rock. The texture and mineral assemblage of the Morton Nice gives clues as to how the rock formed. The fact that it is a crystalline rock with large visible grains, that's these are the grains, and if it was in person, you would be able to see large crystals. It indicates that it originated as a granitic igneous rock that cooled slowly beneath the Earth's surface. The foliated or alignment of the mineral grains indicate that the original rock was subjected to great heat and pressure below the Earth's surface. Gneiss is quarried to use as building stone and monuments. You can find outcrops of gneiss near Morton, the famous Rainbow Gneiss, Redwood Falls, Sacred Heart, and Ortonville. Right, so I'm going to then answer this. So what type of rock is Morton Gneiss? Sedimentary, igneous, metamorphic. Pause and answer that. All right, number 2, click on Greenstone. What was northern Minnesota part of when Greenstone was forming about 2.7 billion years ago? A glacier, a volcanic island arc, a shallow sea, a mountain range. So keep that in your brain while I read this one. So I'm going to return, go to Greenstone. Greenstone in northern Minnesota is somewhat younger than gneiss. Greenstone is a weakly metamorphized altered basalt that is, as its name suggests, greenish to gray. This type of rock formed about 2.7 billion years ago when the area that is now northern Minnesota was part of a volcanic island arc. Much like the islands of Japan are today, Greenstone and other associated volcanic and related rocks have in the past been prospected for deposits of economic metals such as gold, copper, zinc, and iron. Iron mines in Ely and Sudan are now closed. As yet, no other significant metal deposits have been found. Let's go ahead and pause and answer this one, number 2. Right, number 3, click on Iron Formation or Taconite. The black layers in the iron formations of Minnesota contain iron-bearing minerals. What are the names of the 2 most commonly found minerals? Taconite and muscovite, jasper and chert, greenstone and gneiss, magnetite and hematite. So return here. I'm going to click on Iron Formation. Thin layers of iron formation occur within the approximately 2.7 billion-year-old greenstone lava of northern Minnesota. The term is a contraction of iron-bearing formation, which is precisely what it is, a rock having in places as much as 30% iron. Iron formation formed as iron-rich particles precipitated and settled to the seafloor during quiet periods in the volcanic activity. The iron formation we see today consists of thinly layered red, white, and black minerals. The red layers are jasper, the white chert, mostly quartz, and the black are iron-bearing minerals, mostly magnetic, and hematite, non-magnetic. A much younger iron formation, only 1.9 million years old, occurs along the Mesabi Iron Range that extends from Grand Rapids to Babbitt. The iron formation above formed by the same process, but its deposition also involved interplay among seawater, surface rainwater, volcanic activity, and some of the world's oldest life forms. When upgraded in iron content by industrial processing, rocks of the Mojave Range yield an important ore called taconite, and that's what this is right here. All right, so go ahead and answer number 3. And then number 4, when upgraded in iron content, what important ore do the rocks of the Mojave Range yield? So you can rewind if you want to hear that reading again. So what was it? Taconite, hematite, magnetite, jasper. All right, question 5. Click on granite. Granite is an igneous rock. Igneous rocks are either extrusive or intrusive depending on where they form. Is granite extrusive igneous or intrusive igneous? So A, granite formed on the surface of the earth, so it is an extrusive igneous rock. B, granite formed deep below the surface, so it is intrusive. So deep below, intrusive, or on the surface, extrusive. So let's go to granite. Right here. Granite is found throughout northern and central Minnesota. It varies in age from 2.6 billion years in the Minnesota River Valley and northern Minnesota to about 1.7 billion years near St. Cloud. Minnesota granites are composed predominantly of minerals feldspar, quartz, mica, and hornblende. These rocks form deep below the surface in the roots of major mountain ranges. These once deeply buried rocks are now exposed at or near the surface due to uplift and erosion. Granite is quarried for use as building stone and monuments. You can find outcrops of granite in Stearns, Pine, Mille Lacs counties, and also in places in northeastern Minnesota, including the Boundary Waters Canoe area. Pause and answer the next question. All right, number 6. Click on mica schist. What type of rock is schist? Sedimentary, igneous, metamorphic. Just as today, the erosion of ancient rocks produced sediment, these sediments, fine-grained sand and mud, were later deformed by the same processes that caused the uplift of mountains in northern Minnesota. The resulting high temperatures and pressures formed metamorphic rocks called schist. Schist is composed predominantly of mica minerals, which impart a platy or layered texture to the rock. Schist is common in central Minnesota and across northern Minnesota. Go ahead and answer that. All right, and this isn't necessarily the answer, that's just what I was clicking. So what did the quartzite in southwestern Minnesota come from? Water braided in streams, reddish quartz sand grains, pipestone, a thin claystone layer. So let me go here. Quartzite. So not long after the mountains were uplifted across central Minnesota, sand began to accumulate in braided streams in southwestern Minnesota. These stream deposits of reddish quartz and sand grains were eventually consolidated and slightly altered into a very hard rock called quartzite. That's this one right here. The reddish to purple Sioux quartzite at the surface near Blue Mound State Park and Jeffers petroglyphs in southwestern Minnesota. At the Pipestone National Monument, the soft red pipestone the Indians favored for carving is a thin claystone layer that is sandwiched between thick layers of quartzite. So this is what they would carve into. All right, go ahead and answer that one. Number 8, click on basalt. The abundant dark red basaltic rocks now exposed along Lake Superior's north shore are there due to what ancient events? The formation of a new ocean basin, the massive outpourings of lava through cracks along the rift, gas being trapped within the lava as it cooled, cavities filled by agates. Click on basalt right there. About 1.1 billion years ago, the continent had been building for billions of years, began to split across what is now Minnesota. The mid-continental rift, as it is called, is where the crust began to separate to form a new ocean basin. The same process is currently underway between Africa and Saudi Arabia. The rifting process stopped short of producing a new ocean basin in central North America, but the abundant dark red-brown basaltic rock, now exposed along Lake Superior's north shore, are a testament to the massive outpourings of lava through fractures or cracks along the rift. Gooseberry Falls State Park is an ideal place to explore the ancient lava flows. All right, you can go ahead and answer that next one. All right, number 9, click on Gabbro. What type of rock is Gabbro? Sedimentary, extrusive igneous, intrusive igneous, metamorphic. Gabbro is an intrusive rock formed when molten rock is trapped beneath the land surface and cools into a hard, coarsely crystalline mass. It is the intrusive equivalent to basalt. Minnesota's best examples of gabbro are in the part of 1.1 million year old mid-continental rift exposed in the large hills of Duluth, known as the Duluth Complex. The rock is dense, dark-colored, and contains varied percentages of the minerals plagioclase, pyroxene, and olivine. The Duluth Complex contains extensive but relatively low-grade deposits of copper, nickel, and platinum group elements. None are currently being mined. Pause and answer number 9. Number 10, click on agate. What brought Lake Superior agates from northern Minnesota to other areas throughout the state? So, Minnesota's state rock is the Lake Superior agate, so named because it is found predominantly along the coast of Lake Superior. Agates form in cavities in basalt. As mineral-rich water circulates through the cavities, silica and quartz is deposited in thin layers along cavity walls. Eventually, the cavities completely fill with this banded variety of quartz. The color variations are due to slight mineral impurities in the water. Iron, for example, causes much of the red and orange color seen in Lake Superior agates. All right, click on sandstone. What covered most of Minnesota when sandstone and other sedimentary rocks were being deposited? Shallow seas, glaciers, volcanoes, deep oceans. A major time period when sandstone, along with other sedimentary rocks in Minnesota, were deposited was during the early Paleozoic era, about 500 million years ago. At that time, Minnesota was near the equator, and shallow seas covered most of the state. Sediment eroded from upland areas was transported to the seashore, and coarser sediment eventually formed the sandstones seen today in southern Minnesota. Some of these sandstones are so poorly cemented that the grains can be rubbed off with your finger, just like this picture. As the sandstone eroded, piles of clean quartz sand are formed. All right, and last one, limestone. Fossils of what type of organisms can be found in limestone? Organisms that lived on land, organisms that flew in the air, organisms that lived in the water, or that lived in trees. So we're going to click on limestone. Farther offshore away from the beach, finer grained sediment accumulated and chemical sediment precipitated to form limestone and closely related rock called dolostone. In this environment, marine life was abundant. Shells and skeletons of various clams, snails, corals, etc. were preserved in the limestone in southern Minnesota. Limestone is typically tan to gray. It may be massive or bedded in layers with sandstone and shale. In places, fossils may be readily found. All right, go ahead and answer that, and good luck. Have a great day.